Hello students, today we are going to start a new point, that is the fundamental laws of logarithms. Okay, so first law is if m n are positive rational numbers, then log of mn to the base a is equal to log n to the base a plus log n to the base a. Okay, so for proving this properties, all the properties, we have to use base as a which is greater than 0. Okay, because if a is less than 0, log is not defined. Okay, so argument and base is always greater than 0 and base is not equal to 1. Okay, now we have to start to prove this. Okay, so if log of product is there, we can write sum of the log of that two numbers. Okay, so how we prove this? We have to take log of m to the base a is equal to x and log of n to the base a is equal to y. Okay, so by using definition of log, if we have to convert this in exponent form, so how we convert in exponent form? This base is as it is, this RHS as a power and argument is equal to RHS here. So a raised to x is equal to m. So if we convert log m to the base a is equal to x in exponent form, we will get a raised to x is equal to m. Similarly, if we convert log n to the base a is equal to y in exponent form, then it is equal to base we have to write as it is, then raised to RHS is equal to argument. So a raised to y is equal to 10. Okay, now we have to take mn, product of these two numbers. So m into n, that is a raised to x into a raised to y. Okay, so mn is equal to a raised to x into a raised to y. So here base is same, so we can add exponent by laws of indices. So a raised to x plus y. Okay, now again if we convert this form into logarithm, so how we convert this? So log of mn, okay, we have to take RHS or single number as an argument to the base as a here base is a is equal to x plus y. Okay, so log of mn to the base a is equal to x plus y. So value of x is log n to the base a and value of y, that is a log n to the base a. Okay, so we proved here log of mn to the base a is equal to log n to base a plus log n to the base a. Okay, understand this? So if suppose log of 2, log of 6 to the base 2, so this we can write log of 6, we can write 2 into 3 to the base 2, and this product we can write in summation, that is a log of 2 to the base 2 plus log of 3 to the base 2. Okay, and then we can simplify this. So understand this. This is an example of this law. Okay, this property we can generalize also. Means if suppose product of three numbers is there to the base, log of mnp to the base a, so we can write log m to base a plus log n to base a plus log p to the base a. Okay, similarly if n numbers are there, x1 into x2 up to xn to base a, then we can write log of x1 to base a plus log of x2 to base a and so on, log of xn to the base a. Okay, so we can generalize this also. Now we will take second law. The second law is if m n are positive rational numbers, then log of m by n to the base a is equal to log n to base a minus log n to base a. Okay, so similarly, like addition means product, we can write in addition. So here division of log means log division of two numbers, we can write in subtraction. Okay, so again we have to same like this way, log of m to the base a, we have to suppose that x, and log of n to the base a, we have to suppose as a y. Then if we convert in exponent, a raised to x is equal to m. Okay, base as it is, this RHS we have to take as a power, and then is equal to, we have to write argument. Okay, similarly here log n to the base a is equal to y, we can write a raised to y is equal to n. Okay, now we want m by n, so we have to take m upon n is equal to a raised to x upon a raised to y. Okay, so if m by n is equal to a raised to x upon a raised to y, then by laws of indices we can write here base is in, so a raised to x minus y. Okay, now we have to write in log format, so log of m by n to the base a is equal to x minus y. Okay, log of this to the base a is equal to x minus y. Okay, now log of m by n to the base a is equal to x minus y. So this x means log of m to the base a. So this is log of m to the base a minus y means log of n to the base a. So log of m by n to the base a is equal to log n to the base a minus log n to the base a. Okay, now we will take third law. Third law is if m, n are positive rational numbers, then log of m raised to n to the base a is equal to n log m to the base a. Okay, means if argument raised to something is there, then we can take this power in front of this law. Okay, means here suppose I will take first example, suppose log of 2 cube to the base 3, then this we can simplify as a 3, this exponent we take as a coefficient of this, so 3 into log of 2 to the base 3, and then we can simplify. Okay, so if argument raised to some number is there, then we can take as a coefficient. Okay, but if it is a log of 2 to the base 3 and here it is a power, then we can't take this as a coefficient. Okay, if argument raised to some number is there, then we can take as a coefficient, but log 2 to the base 3 and here it is power, meaning of this is log of 2 to the base 3 bracket cube. Okay, so this and this is different. Okay, now we will prove this property. Okay, so log of m raised to n to the base a is equal to n log m to the base a. Okay, so we have to suppose that log m to the base a is equal to x. Okay, so that log n to the base a is equal to x. So if we convert in exponent, a raised to base raised to RHS is equal to argument. So a raised to x is equal to m. Now I want here m raised to n. So I am raising the power of both sides by n. So a raised to x raised to n is equal to m raised to n. Okay. Now here we have to find the log of this. Okay, so by definition of log, how how we write this? Okay, so a raised to x raised to n is equal to m raised to n. So here we can write a raised to nx is equal to m raised to n. Okay, now if we convert this in log, so log of m raised to n to the base a, here base is a, is equal to nx. Okay, I'm taking this as a single number, so m raised to n, log of m raised to n to the base a is equal to nx. So n into value of x is log n to the base a, so n into log m to the base a. So log of m raised to n to the base a is equal to n into log n to the base a. Okay, so understand this property. These are all our important properties. Okay, now we will take fourth law. Fourth law is log of 1 to the base a is equal to 0. So that is the log of 1 to any base is 0. Okay, so value of log 1 to any base is 0. Okay, so how we prove this? Since a raised to 0 is equal to 1, any number raised to 0 is 1. So if we convert this in log format, so log of 1, okay, so log of 1 to the base a is equal to 0. Log of this RHS to the base a is equal to 0. Okay, so log 1 to the base a is equal to 0. So if means any number raised to 0 is 1, so log 1 to the base a is 0. Okay, so log of 1 to any base is 0. Okay, similarly we have to prove fifth law. Okay, fifth law is log of a to the base a is equal to 1. That is a log of any positive quantity with the same base, then it is a 1. Okay, so how we prove this? We know that a raised to 1 is equal to a. So if we convert in log, so log of a, this a to the base a, this base is equal to 1. Okay, so if a raised to means a raised to 1 is equal to a, then log of a to the base a is equal to 1. So if argument and base is same, then that answer is a 1. Okay, so log of any positive quantity of the same base is 1. Okay, understand this? Now we will take sixth law. Okay, an example of this, if suppose if we take log of 2 to the base 2, then this answer is a 1. Okay, now we will take next law. Sixth law is if m is positive rational number and a, b are positive real numbers such that a not equal to 1 and b also not equal to 1, then log m to the base a is equal to log m to the base b upon log a to the base b. Okay, so this is actually base changing law. Okay, we can write here this as a base, or we can say it as a base changing theorem. Okay, so this sixth law as a base changing theorem. If we have to change the base, here base is a, and if we have to change base as a b, okay, then we have to use this log m to the base a is equal to log m to the base b upon log a to the base b. So okay, so how we means this formula we keep in mind. If suppose means same here, if I am taking log m to the base a and I have to change base as a b, so first we have to write numerator and denominator. First write log, then base write as a b, which we have to change. Okay, here it is a, you have to change as a b. Okay, and then write argument here in numerator and base right here. Okay, so log m to the base a is equal to log m to the base b upon log a to the base b. Okay, So now we will see how to prove this. Okay. So first we have to suppose that log m to the base a is equal to x. Okay. Now if we write in exponent format, so it is a raised to x is equal to m. Okay. Now we have to take log on both sides as a base b. Okay. So if we take log on both sides, so log of a raised to x to the base b is equal to log of m to the base b. Okay, so here I am taking log on both sides as base b. Okay, so I am taking log a raised to x, taking base as a b, so log a raised to x to the base b is equal to log m to the base b. Okay, now we have log, if log of a raised to x is there, if argument raised to power is there, some power is there, then this power becomes a coefficient, so this x becomes coefficient, so x into log of a to the base b is equal to log m to the base b. Okay, now I will write here. Okay, so this x I can replace by log m to the base a, so log m to the base a into log a to the base b is equal to log m to the base b. Okay, now log m to the base a is equal to log of m to the base b upon log of a to the base b. Okay, so this is the proof of this law. Okay, so if we have to change the base, then we have to use this law. Okay, understand this. Now in this law, if we replace m or sorry, if we replace b by m, okay, then what we will get? So log of m means I am changing base a as a base m. Okay, so if we replace b by m, so log m to the base a is equal to log m to the base m upon log a to the base m. Okay, so if base and argument is same, by law of logarithm, if base and argument is same, that answer is 1. So 1 divided by log a to the base m, so log of m to the base a is equal to 1 divided by log a to the base m. So if we change the position of argument and base, see here argument is m, base is a. Okay, and here argument is a, base is a. So if we change the position, it is equal to 1 upon log of a to the base m. Okay, so there is another law, okay, which we proved by using this law. Okay, so log of m to the base a is equal to 1 divided by log a to the base m. So if we change place of argument and base, it is equal to 1 upon log of a to the base m. Okay, now we will take next law. The seventh law is, if a is a positive real number and n is a positive rational number, then a raised to log of n to the base a is equal to n. Okay, means if this base and this base is equal, then answer is directly argument. Okay, so how we prove this? Log of n to the base a, we have to suppose that x. So by definition of log, a raised to x is equal to n. Okay, so here a raised to x is n, means x value is log of n to the base a. So a raised to value of x is log n to the base a, so log n to the base a, that is equal to n. So a raised to log of n to the base a means this base and this base is equal, then it is equal to argument. Okay, for example, if we take log of 8, sorry, 2 raised to log of 8 to the base 2, then answer is 8. Okay, or we can write like this way, 3 raised to log of 7 to the base 3. Okay, then here this base and this base is 3, so answer is 7. Okay, understand this law. Now we will take 8th law. The 8th law is, if a is positive real number and n is a positive rational number, then log of n raised to p to the base a raised to q, here n raised to p as an argument, a raised to q as a base, then we can write p by q into log of n to the base a. Okay, so already we learned that if log of, suppose n raised to p is there and to the base a, then we can write p into log of n to the base a. Okay, but if base raised to something is there, so suppose a raised to q is there, then this q comes in a denominator, so p by q log n to the base a. Okay, so we have to prove this law. So how we prove this law? We have to suppose that log of n raised to p to the base a raised to q is equal to x, and this log n to the base a is y. Okay, so from this, if we convert in exponent, here we have write and a log n to the base a is equal to y. So if we convert in exponent, a raised to q as a base raised to this x is equal to n raised to p, and from this a raised to y, a raised to y is equal to n. Okay, now this we can write a raised to qx is equal to n raised to p, and a raised to y is equal to n. Now a raised to y is equal to n, so value of n, if we substitute here, so we will get a raised to qx is equal to n, that is a raised to y, so a raised to y raised to p. Okay, so a raised to qx is equal to a raised to py. So here base is same, so we can compare or we can equate exponent. So qx is equal to py, so value of x is p by q into y. Now again resubstitute value of x and y. So value of x is this log of n raised to p to the base a raised to q is equal to p by q, and value of y is log n to the base a. Okay, understand this? So suppose if we take example of this law, log of, suppose 3 square is there and here to the base 2 raised to 3, then we can write this 2 in numerator, this 2 in numerator. Okay, coefficient of log we can write 2 is in numerator, this 3 is in denominator. 2 by 3 into log of 3 to the base 2. Okay, so this we can simplify as this way. Okay, by using this law. Understand this? I will take afterwards all the laws together. Okay, now we will take some result of logarithm. Okay, now we will see some useful results. So first result is, if a greater than 1 means base is greater than 1, then log of x to the base a is less than 0 for all x satisfying x is greater than 0 less than 1 means if I am taking a is equal to 2, okay, so log of x, if I am taking in between 0 to 1, so suppose I am taking log of 1 by 2 to the base 2. So if we solve this, then answer is minus 1 means when we raise the power of 2 by minus 1, then we will get 1 by 2. Okay, so this value is less than 0 for all x satisfying this condition means when we take x greater than 0 and less than 1, that is 1 by 2, 1 by 4, then this value log x to the base a less than 0. Okay, understand this? Then again if we take log x to the base a, if log x to the base a is 0, then value of x is 1, that is a property. Okay, so suppose if I am taking log a is 2, again same, then log of 1, if x is 1, so log of 1 to the base 2 is 0. Okay, because if we raise the power of 2 by 0, then we will get answer is 1. So log x to the base a is 0 is equal to 0 for x is equal to 1, and log x to the base a greater than 0 for x greater than 1. See, so if I am taking a is 2 and x is greater than 1, so suppose I am taking x is 4, so log of 4 to the base 2, so by which number when we raise power of 2, then we will get 4, then that answer is 2. Okay, so 2 square is 4, so this is greater than 0. Okay, for x greater than 1. So understand this result. So log x to the base a less than 0, when it is less than 0 for all x satisfying this condition, that is x is in between 0 to 1. Okay, this condition we are discussing for only if a greater than 1. Okay, next result we will discuss for a is in between 0 to 1. Okay, so first result we discuss for a greater than 1. So if base is greater than 1, then okay, base is not equal to 1, so there are two parts, either it is greater than 1 or it is in between 0 to 1. Okay, so first we will discuss for a greater than 1. So if a greater than 1, then log x to the base a less than 0, when it is less than 0, if x satisfying this condition means if x is in between 0 to 1, then log x to the base a less than 0. Okay, we can means we can decide the sign of this log by using this graph also. Okay, this is the graph of y is equal to log x to the base a when a greater than 1. So this is the increasing function. Okay, so we will see here x greater than y. So if x greater than y and if a greater than 1, then log x to the base a greater than log y to the base a. Okay, we can take example, suppose here 8 greater than 4, then if we take log of 8 to the base 2 and log of 4 to the base 2. So if we find this answer log of 8 to the base 2, that is a 3, because when we raise power of 2 by 3 we will get 8. When we raise power of 2 by 2, that is a 4, we will get 4. So answer of this is 2. So 3 greater than 2, so therefore log 8 to the base 2 is greater than log of 4 to the base 2. Okay, so when a greater than 1, if a greater than 1, then x greater than y, if it is, then log x greater than log y to the base a. So this is increasing function when a greater than 1. Okay, so understand this 4 result. If a greater than 1, then we can use this 4 result. Okay, log x to the base a less than 0 for all x satisfying x is in between 0 to 1, log x is equal to 0 for x is equal to 1, log x greater than 0 for x greater than 1, and if x greater than y, log x greater than log y. Okay. Now we will discuss second result. If a is greater than 0 but less than 1, means if a is in between 0 to 1, then what are the results? Okay. Now we will discuss result 2. If a is in between 0 to 1, okay, so if value of a, that is a base, is in between 0 to 1, then first result is log x to the base a less than 0 for all x greater than 1. So if I am taking, suppose a is equal to 1 by 2, then log of x, if I am taking x is greater than 1, so suppose I am taking x is 2 and base is 1 by 2. Okay, so value of this is log 2 to the base 1 by 2 is minus 1. Okay, so this value is less than 0. Okay, so which power we have to raise to 1 by 2? So we will get 2, that is a minus 1. Okay, so if I am taking a is in between 0 to 1 and x is greater than 1, then log of x to the base a is less than 0. This is first result. Okay. Second result, if x is equal to 1, then that value is a 0. So log 1 is 0. Okay. There is means if a is greater than 1 or if a is in between 0 to 1, this is answer is 0. Means log 1 is 0 because any number raised to is 0. Any number raised to 0 is 1. So log of x for any base, that is a 0. Okay, for x is equal to 1. Then third one, log x to the base a greater than 0. When it is greater than 0, for all x satisfying 0 to 1. So suppose I am taking a is same, that is 1 by 2, and log of 1 by 4 I am taking to the base 1 by 2. So which power we have to raise to 1 by 2? So we will get 1 by 4, that is 2. So if we take power of 1 by 2 is 2, then we will get answer is 1 by 4. Okay, so this is greater than 0 for all x satisfying this condition, 0 to x is in between 0 to 1. So when I am taking x is in between 0 to 1 and base is also in between 0 to 1, then log x to the base a greater than 0. Okay, understand this? Now fourth result is x greater than y. If x greater than y, then log x to the base a less than log y to the base a. Okay, when it is, if a is in between 0 to 1. So if I took example like this way, 8, same example, 8 greater than 4. Okay, so log of 8, if I am taking log to the both sides, so log of 8 and here log of 4 to the base I am taking 1 by 2 for both. So which power we have to raise to 1 by 2? So we will get answer is 8, that is a minus 3. Okay, and here which power we have to raise to 1 by 2? So we will get answer is 4, that is a minus 2. So between minus 3 and minus 2, or among minus 3 and minus 2, which one is greater? Minus 2 is greater. Okay, so log of 4 is greater than log of 8. Okay, so in this case this function is decreasing. When it is decreasing, so y is equal to log x to the base a when a is in between 0 to 1. So if a is in between 0 to 1, log function is a decreasing function. Okay, understand this? So if a is in between 0 to 1, then log x is less than 0 for all x greater than 1. Log x is equal to 0 for x is equal to 1. Log x greater than 0 for all x satisfying 0 to 1, means x is in between 0 to 1. And if x greater than y, then log x less than log y. This is important property. Okay, if x greater than y, then log x is less than log y when a is in between 0 to 1. Okay, but when a is greater than 1, then log x greater than log y. Okay, understand this. So after that we will discuss some result. Okay, and then we will discuss about natural law and common law. Okay, now we will discuss third result and fourth result. Okay, if a greater than 1, then log x to the base a greater than 1 if x greater than a. Means if I am taking a is equal to 2, okay, and if x is greater than a, so suppose I am taking x is equal to 8, suppose, then log of x, that is a log of 8 to the base 2, that is a greater than 1. So log 8 to the base 2 is 3, because when we raise the power of 2 by 3 we will get 8. So this answer is 3. So log of 8 to the base 2 is 3, so 3 greater than 1. So if a greater than 1 and if x greater than a, then log x to the base a greater than 1. Similarly, a greater than 1, so if I am taking a is equal to 2 and if x is in between 0 to a, so if I am taking x is equal to suppose 1 by 4, then log x, that is log of 1 by 4 to the base 2 is less than 1. Okay, because log of 1 by 4 to the base 2, that is this answer we will get minus 2. Okay, when we raise the power of 2 by minus 2 we will get answer is 1 by 4. Okay, so this minus 2 is less than 1. Okay, so if log x to the base a less than 1 if x is in between 0 to a. Similarly, log x to the base a is equal to 1 if x is equal to a. So if argument and base is same, answer is 1. Okay. Then fourth result, if a is in between 0 to 1, then log x to the base a greater than 1 if x is in between 0 to a. So if I am taking suppose a is equal to 1 by 2, that is in between 0 to 1, x I am taking between 0 to a. So suppose x is equal to 1 by 4. So log of 1 by 4 to the base 1 by 2. So this answer we will get as a 2, because when we raise the power of 1 by 2 by 2, then we will get answer is 1 by 4. So this is greater than 1. So if a is in between 0 to 1 and x is in between 0 to a, then log x is greater than 1. Then log x is equal to 1 if x is equal to a. So same when argument and base is equal, then answer is 1. Then log x to the base a less than 1 if x greater than a. So if I am taking log of x suppose greater than 2, so suppose I am taking x is 2, okay, and this a is in between 0 to 1, so it is 1 by 2. So when we raise power of 1 by 2 by minus 1, then we will get answer is 2. Okay, so answer of this is minus 1 and which is less than 1. Okay, so if x greater than a and a is in between 0 to 1, then log x to the base a less than 1. Okay, understand these results. Actually these results are useful for solving logarithmic inequalities. Okay, but in 11th standard we have only solved logarithm, means calculation. So this is not that much important for 11, but it is important in class 12. Okay, because in class 12 we have to solve logarithmic inequalities. Okay, but keep in mind this. Now we will discuss about system of logarithms. Okay, there are two systems of logarithms. First one is common logarithms and second one is natural logarithms. Okay, common logarithms also called as a brick system. Okay, if suppose in log base is not given, then we have to consider base is a 10. Okay, so suppose it is given as a like this way, log of 25, then it means log 25 to the base 10. Okay, so if base is not mentioned, then we have to consider that base as a 10. Okay, this is called as a common logarithms. Okay, and in this lesson we have to use this common logarithm. Okay, so base is not mentioned, in that case take base as a 10. And natural logarithms, that is a logarithm which have base is equal to e. Okay, so e means it is a like pi. So if e base is there, then that log is called as a natural logarithm. Okay, means suppose if log of x to the base e, then this is called as a natural logarithms. Okay, and this e is an irrational number. Okay, so this e is an irrational number, and approximately value of e, that is equal to 2.7. Okay, so this e is an irrational number, value of e up to 1 decimal, so approximately this value is 2.7. This is irrational, so actually decimal expansion is non-terminating, non-recurring, but for solving examples we have to consider this value as a 2.7. Okay, same like pi, if we consider, means for solving examples we have to consider value of pi is 3.14. Similarly we have to consider value of e is 2.7. Okay, but it is an irrational number, and for means functions in lesson function or in calculus we have to use this natural logarithms. Okay, so this is denoted as a ln x, that is a, when it is denoted like this way, ln of x means ln x, that is a natural logarithm. In that case base is e. Okay, so this is called as a natural logarithm, but in this lesson we have to use only this common logarithms, that is the base is a 10. So these are two systems of logarithms. After that we will take examples based on this all properties.